In this tutorial we're going to look at using graphs to solve equations. Now some people really don't like this, but actually it's not too difficult. Right, first of all we may be asked to plot the graph, usually from a table first, but in both my questions actually the graph is given to us. Now the first thing to know is that the solutions are always read off this axis. Okay, it's always done in terms of x, and so the solutions are always read off the x-axis. Now, if you're given a graph of y equals f of x, then the solutions of f of x, whatever that happens to be, equals 0 are just where the graph cuts the x-axis. Okay, now we're going to pause there in our key points and actually do question 1. We'll look at the next bit in a minute. So question 1 is just that. We're given the graph of y equals x cubed minus 2x squared minus 3x plus 3 and asked to solve x cubed minus 2x squared minus 3x plus 3 equals 0. So it is the same thing. Y equals f of x and f of x equals 0. And so we just take the points here. 1, 2, 3. You can see I've just put red dots on those. I'll just highlight them a bit more for you, where it crosses the x-axis, and we can simply, and it really is simple, read off. It's asked me to do it to one decimal place, and you can see you just have to decide whether it's closer to minus 1.4 or minus 1.5. I think that's minus 1.4, the left-hand point. The middle one is x equals 0.8, slightly closer to that than 0.7. And the next one is x equals 2.7. So to the nearest grid line, minus 1.4, 0.8 and 2.7. And in those cases it really is as simple as that. Okay, let's look at question 2. Go back to the key points. Number 3 here, if we're given not f of x, in other words, not the thing that we've drawn the graph of, but something different, and you can see in this question, same graph as we had in question 1, but different equation equals 0. Okay, instead of minus 3x plus 3, it's minus 2x plus 2. And usually they will say by drawing a suitable straight line. Okay, and the way we do it is the first thing we do is we rearrange g of x equals 0, rearrange it into f of x, so we've got the thing we've drawn, equals something x plus something. And the reason I've written it as mx plus c is because we're then going to draw the line y equals mx plus c, and the solutions will be the x-coordinates again. So the x-coordinates, read it off the x-axis of where the line and the curve cross. Okay, don't forget that solutions may also be called roots, but normally they call them solutions. Okay, so let's see what we're going to do here. We're going to take the highlighted equation at the bottom and make it look like the function we've got at the top. So what we actually want is, and it's quite a good idea just to write it down, x cubed minus 2x squared minus 3x plus 3 equals something. Well, how do we get from the top one to the bottom one? Minus 2x, take away an x gives me minus 3x, and add the 1 takes me from 2 to 3. But it's an equation, so I have to do the same to the other side, minus x and plus 1, and that gives me, unsurprisingly, minus x plus 1 on the other side. So now we simply draw y equals, oops, I need a minus sign in there, minus x plus 1. And if you don't know how to do that, you need to look at the tutorial on drawing straight lines. But I hope you know that it crosses the x-axis at 1, that's the plus c. Sorry, it crosses the y-axis at 1, that's the plus c, that's the y-intercept, so it goes through this point here. And it has a gradient of, well, m is the gradient, and m is this minus 1 in front of the x. So using the scales carefully, if I go 1 across, I go 1 down and get to that point. 1 across, 1 down. And so here I am doing a gradient of minus 1. And if I extrapolate that backwards, I can see that that is my straight line. And so I simply draw a straight line, as straight as I can, with a ruler through those points. And then, having done that, it's these crossing points here that I'm looking at, okay? And I put red dots on them again. I will just highlight them again for you. Okay, so we're looking for the x-coordinates of those 3 points. And so we can just draw a straight line down to the axis here. Okay, that straight line there is going to be very short. And then we draw a straight line here up to the axis here. And again, to the nearest grid line, we can see that x is equal to, looks to me to be about minus 1.1, where my lines hit the axis, and then about 0.7, and then at about 2.5. Okay, if you get them 0.1 out from those, that's probably fine. Okay, so the first question was relatively straightforward. This one was a bit more difficult, but as I say, you just make the left-hand side of the equation look like the function you've been given and adjust the right-hand side, draw the straight line, and find the x-coordinates of the points of intersection. And that's what you do.